What if your AI stopped just answering questions and started actually doing your work? Imagine an assistant that doesn't just suggest a flight, but books it, manages your entire schedule, and completes your research while you sleep. We are officially entering the agentic era, moving past chatbots into a world of autonomous agents that reason, plan, and execute. But there's a technical bottleneck. To make AI this responsive, we need processing power traditional hardware simply can't handle. Google's answer? A revolutionary two-chip solution, the TPU-8T for deep study and the TPU-8i for lightning-fast action. We're breaking down how these new AI brains work and how Google plans to bring high-speed agentic AI to the masses. The era of the chatbot is over. The era of the agent is here. Let's dive into the hardware making it possible.
So Google just did something pretty huge in the world of AI. And no, it's not another chatbot or a cool new app. We're talking about something way more fundamental, the hardware, the actual brains that are going to power everything. They just pulled the curtain back on two new specialized computer chips designed to change how AI works for all of us. But before we get into all the techie details, let's just zoom out for a second and think about the big picture. What if AI could really do things for you? And I don't just mean answering a quick question. I mean, what if it could book your entire vacation, sort out your chaotic schedule, or research a super complex topic from start to finish all by itself?
Well, that future actually has a name. Google is calling it the Agentic era. It's their vision for a world where these autonomous AI agents can actually reason, plan, and then go and execute complex, multi-step tasks for you. This is the big goal, right? This is what all this new tech is building toward.
But as you can probably guess, a vision that big creates an equally big technical challenge. I mean, building these agents is a whole different ballgame than making a simple chatbot. It needs a completely new kind of power under the hood. This right here breaks down the core problem perfectly. It's like a tug of war. On one side, you've got the AI's brain. It needs to learn from these unbelievably complex models and mountains of information, and that takes a ton of heavy-duty power. But on the other side, you've got us, the user, and we want things instantly. For the experience to feel, magical, the AI has to act right away. Nobody wants to wait around for their AI agent to think. And this is where Google's big announcement comes into play. To solve this two-sided problem, they didn't just try to build one giant, do-it-all superchip. Nope. They got smart about it and took a specialized approach, a two-chip solution built specifically for this challenge. And here they are, the TPU-8T and the TPU-8i. Each one has a very specific job. The T in 8T, that's for training. It's the powerhouse built to chew through those massive, complex AI models. And the I in 8i, that stands for inference, which is really just a fancy way of saying it's designed to get things done, to complete those multi-step tasks really, really fast. It's the doing chip.
Now, this specialization, this is the crucial part. And honestly, the easiest way to wrap your head around it is with a really simple analogy. Just think of it as a split between brains and reflexes.
So here's how it works, in two steps. Step 1 is study. This is handled by the brains chip, the TPU-8T. This is where all the deep learning happens, processing huge amounts of data. And then you have step 2, act. This is the reflexes chip, the TPU-8i, which takes all that learning and puts it into action, executing tasks incredibly quickly. Let's dig into that a little more. The TPU-80, the brains, you can picture it spending all its time in a massive, endless library. Its only job is to read, learn, and absorb the most complex information it can possibly find. This is the slow, deep thinking that makes the AI genuinely smart. And then you've got the TPU-8i, the reflexes. So if the other chip is tucked away studying in the library, this one is sitting in the front row of the class, hand raised, ready to go. As soon as the learning is done, this chip is optimized to give you a fast, correct answer or action the second it's called upon. This is what's going to give you that instant, seamless user experience. So, okay. Specialized chips for brains and reflexes, it's a really clever solution. But why does this super technical update actually matter to you and me? What's the real-world impact here? Well, the ultimate mission behind this whole system, the chips, the data centers, all of it, is summed up perfectly in this one quote from Google. Their goal is to bring highly responsive, agentic AI to the masses. This isn't just about a tool for researchers in a lab. It's about building the foundation to make this incredibly powerful technology available to everyone. So what does this system actually unlock for us? Well, for starters, it means AI assistants that are not only way faster, but way more helpful and capable. It means AI that can finally handle those complex, multi-step projects we were just imagining, the kind that need actual reasoning and planning. This two-chip system, it really is the engine for the next generation of AI tools.
And that leaves us with one last big thought. Once this technology is really in our hands, and you have an AI agent that can plan and execute these complex tasks for you, what's the very first thing you would ask it to do?